Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have a returning guest from a long time ago, Dr. Zack Abbott. He's the CEO and co-founder of ZBiotics. Zack is a PhD in microbiology and immunology from University of Michigan. He has a bachelor's from UC Berkeley. He double majored in immunology and classical art and archaeology there. We're going to talk about his product, ZBiotics, and what's its use and why, and all the nuances of that. So, Zack, welcome back.
Yeah, great to be back. Thanks for having me. Excited to chat with you.
Well, good. For people that haven't heard before, tell me a bit about your background and how you got into the world of probiotics, alcohol, and things like that.
Sure, absolutely. Yeah. So, as you said in the kind of the bio, the intro there, my background, I did a PhD in microbiology. Before doing my PhD, I was working in an HIV lab doing academic research. I've always been really passionate and interested in biology, in particular microbiology and the impact of microbes on our lives. I think I went into the field, the underlying interest was really around like solving problems or making people's lives better in some way. And the obvious kind of entry level for that was disease, and disease prevention was, I think, how I first thought about microbes, as most people do. I think of microbes and viruses and bacteria as sort of these agents of damage or chaos. But one of the things I grew to realize as I was doing my PhD, where I was studying bacteria, was that the vast majority of bacteria actually are incredibly important and beneficial, or at a minimum are neutral towards humans. It's really a small percentage of them that end up causing infections. And so looking at like all of the underlying processes in the world that are really like driven fundamentally by the activity of microbes, and in large part a lot of times by bacteria, I got to be really excited about how we could leverage them for good rather than combat them for bad.
For the average person, is it mistaken for them to think of all bacteria and viruses and all that as bugs and bad and, pathological and all that? Sound not.
Exactly. Yeah. I definitely think that we in this case, it's like, science, microbiology knows that microbes in large part are very good. They are actually fundamental to our existence on this planet. That's true for pretty much all life. So that being said, of course, there are they sort of like the disease-causing, the pathogenic bacteria, viruses, but most are quite good. So yeah, so sort of evolving that understanding and that belief and thinking about how we live as in an ecosystem and really as an ecosystem for bacteria. Like if I think one of the fun statistics that I talk about that I think a lot of people probably have heard before is that you have as many bacterial cells in your gut as you do human cells in your whole body. So really, like the bacteria that are in us and on us, numerically speaking, really like outnumber us. Think of ourselves as like sort of walking around as human. The reality is that like we're sort of like this like walking pond or like ecosystem for all these bacteria. And it is in large part very symbiotic, right? That a lot of the bacteria that live in us and on us are performing a lot of valuable, essential functions for our survival, not absolutely essential. So, in terms of our ability to honestly like our emotional stability, our sleep patterns, our diet, our ability to combat infections, the development of our neurological systems, all these things are like driven or benefited in part by the fact that we have these bacteria, these microbes kind of living in and on us. So I became really, kind of looping this back to my interest, I became really fascinated with how important these bacteria are and what role are they playing. And then kind of as our understanding of this has vastly increased in the last 20 years, are there ways now that beyond just understanding it, are there ways that we can leverage it to kind of benefit our health more, understanding that this relationship is so important. So I think that's kind of what drove me or led me to ZBiotic, was that idea.
I don't know if there's numbers out there, but approximately what percentage of bacteria are beneficial or at least not pathological, and what percentage are pathological?
Yeah. So to pass along a number I've heard that I've never really validated or verified, and I don't know if we could ever even actually know it, but truthfully, the number I've frequently heard tossed around is about 1%. That about 1% of bacteria are pathological to humans in some way, and the other 99%. Truthfully, I think that's probably an overestimation. I think it's probably a lot less than 1%. There's so many different kinds of bacteria out there. But at a minimum, you could say, I think at a qualitative level, the vast majority of bacteria are either neutral or beneficial, and only a very small percentage are pathological.
Is there any indicator or number that talks about the cooperative nature of a particular strain or species of bacteria? Are some a lot more, cooperative than others, where they form more biofilms and they work together, and others maybe more mercenary or more loners? Has that been quantified for any particular bacteria?
I don't think we're at a stage right now where we can really adequately quantify the level of participation, given that I think first and foremost, one thing we do know is that everybody's microbiome and biology is different. And yet there is no finite number or characterization of a healthy microbiome. So that kind of ecosystem of bacteria that are living in your gut can be very different from one person to the next. And even if they're very different, they both can be really healthy or beneficial. And so I think, if you think of it again as sort of like an ecosystem, many different ecosystems can be stable and beneficial, and the different microbes that are in. So a bacteria that's in my gut may be very beneficial and stable and in there for a very long period of time and performing some very valuable function. And then that same bacteria may not be able to have any play in your gut at all, or it could be a totally transient member, but somebody else is in your gut and kind of filling in that same niche or serving that same purpose in your ecosystem. So it really is kind of network dependent, if you think of it as sort of like a network of interactions from bacteria to bacteria to human cell, really.
All right. Well, let's move forward to with ZBiotics. What's the premise of the company and what's the product?
Yeah, exactly. I think the idea is that we could use these bacteria for good. We know you're ingesting these bacteria every day, that some of them are passing through, some of them are taking up residence, and they're doing all these functions on your behalf. So for instance, I mentioned that you have about as many bacterial cells as you have human cells. What's interesting is that human cells are all of my human cells essentially have the same DNA, right? So they have the same roughly 20,000 genes, they encode for 20,000 different proteins, and all of my cells encode for the same 20,000 different proteins. But what's interesting is that even though I have the same number of bacterial cells, all of those bacterial cells encode for different types of proteins, right? So it's actually, you have 1,000-fold more bacterial genes in your body than you do human genes. And so that's 1,000-fold more functions that bacteria are performing. There's a lot more diversity of action happening there. And so I saw that as a huge opening and opportunity, that these bacteria are performing all these functions. And of course, many of them are for the benefit of the bacteria, but a lot of them are at least tangentially, if not directly, for the benefit of the host, for the human.
Can anyone figure out the degree of redundancy to do an actual comparison of, we have, 1,000 times more bacterial genes than we have humans. Maybe the human genes, have more functions than bacteria or not. And again, with the redundancy of certain functions in the microbiome, what does that number actually look like?
Right. So I'm sure people have, can figure that out. And you're quite right, there's a lot of it. Obviously the 20,000 functions that our human cells encode are all important to us. And of course, many of the functions that the bacteria encode are not beneficial to us. They're sort of agnostic to who we are. They're for the benefit of the bacteria, the sort of maintenance things. And you're right that many of them, for instance, all those different bacteria in your gut are all going to be encoding for bacterial DNA replication. And so that'll be a huge redundancy and something that's not really very, very valuable to us. So the number of those functions, that 1,000-fold more functions that are actually useful to us is actually, a lot smaller. That being said, the potential there is that there are such a wider breadth of things that the bacteria can do than we can, right? And so while many of those things may not be directly useful to us, the point is that there's an opportunity for a lot more functions to be happening and ones that could be helpful to us, right? It expands the possible repertoire of things that could happen. If we were limited only to the genes in our own cells, which are relatively fixed, then the number of functions we could do would be restricted. But the fact is, we're ingesting these bacteria that are performing this wide breadth of functions all the time, and that's ever changing. And so it's an opportunity to introduce new functions that you didn't have before, which fundamentally is what made me so excited about ZBiotics and starting the company that would become ZBiotics. We essentially could take a probiotic, a safe edible bacteria that performs, call it 2,000 to 3,000 functions, right? And many of those functions are for the benefit of the bacteria, but we could then use genetic engineering and program that bacteria to perform one additional function. And that function would be useful to you, the human, the person who ingests the bacteria, right? And so if we could reliably get that bacteria to perform that single additional function in addition to the thousands of functions that it was already performing, then we could basically be delivering to you a new function that would create a new benefit to you, the user, the host. And so that was really the idea was, there's all these things. I mean, bacteria can essentially do any biological function on the planet. And to just like zoom in for a second and just define what I mean by function, it's like the idea that like, when you eat food, that is comprised of all these like, nutrients and macromolecules, like big, long proteins and big, long, strings of sugars and all these things, right? And we have to use biochemistry to break those down. Our cells break down those nutrients, or they bind on to to minerals like calcium and iron and absorb them. And all these things are really important for us to survive, right? And that's just nutrients that I'm describing right there, but also like, biological functions to like, how you think and combat disease and sort of like, all these sorts of things that happen are all done based on like, these functions that your cells are performing, right? And so if we could define something that we thought was like really important or really valuable, we could get a bacteria to do that function. Basically, a bacteria can do almost anything. And they've been around for 3 billion years, much, much longer than humans have. And so they're capable of basically performing any biological function. And so that was the idea. Okay, so now we have the whole universe of biological functions that we could potentially program into a bacteria that you could eat. And so then how do we narrow it down to something that would be interesting and useful? And so I started thinking about ways that, or things that we could apply this idea or this technology to. And I quickly kind of decided that I think there's a lot of different directions we could go, but I decided that I didn't want to build drugs. I didn't want to cure diseases myself with this idea. What I wanted to do was make products for healthy people, for people who wanted to like kind of, they're already functioning properly, that want to kind of like level up or be better or more healthy, or help them navigate kind of a world that is in modern society is sort of pushing them to be less healthy, with sort of like highly manufactured foods and like the relative availability of like simple carbohydrates and all these things that like make it really difficult to be healthy. I thought it would be a fun way to bring biotechnology to the average person by like focusing on kind of like making healthy people healthier and helping with like kind of everyday problems rather than like curing. There were a lot of other companies out there that were kind of using this or had proposed using this technology to cure disease. And I thought it was great. I saw a different opportunity basically.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Well, one thing recently I learned that it seems like almost no probiotics take up residence in the gut, but it's in the transit of them is where their action is.
Exactly.
So while they're in transit, that's when they take action. So how do you reconcile that? Do you then provide foodstuffs to the existing bacteria someone has, so now they can unlock an ability or amplify an ability to digest something or produce a certain metabolite? Like, if you have that thinking, how do you choose the right bacteria to affect the existing ones there and partner with them, let's say?
That's a really astute question, and one that, most people who are not microbiologists don't appreciate. It's not, it is, everybody, as I described earlier, everybody's sort of like network of microbes is really complex, and it can be very difficult to reliably get a bacteria to take up residence there. And so indeed, I actually took advantage of the fact that I chose a bacteria that doesn't take up residence in the gut, but reliably passes through the gut in a very like transient way. And so took advantage of sort of like the transient timeline like that. It picked a bacteria that is able to transit through the gut really efficiently and effectively, and it's able to express protein and essentially perform biological functions while it's kind of floating down the river, like down your gut, right? So the idea that you ingest this bacteria and then it passes through your intestines in about 18 to 24 hours and you pass it out. That's very consistent from one person to the next. The bacteria I use is a bacteria called Bacillus subtilis. It's a common microbe found in really ubiquitously. It's on your kitchen countertop. It's in the soil. It's on the surface of fresh fruits and vegetables. And you likely eat it every day of your life. And it's naturally evolved to pass through your stomach acid unharmed and then basically when it gets into your intestines, it wakes up out of a sort of a dormant protected spore form. And once it's woken up, it starts becoming active and it enjoys kind of the float down the river of your gut. There's some nutrients there. And so it kind of takes advantage of that. And then it doesn't want to stay there. It wants to pass out the other side and go back out into the soil. It's an environmental microbe. And so I took advantage of this bacteria that we know is safe, that you eat every day, that is like already has all the toolkit ready to kind of just naturally pass to your gut, and say that, okay, as you're floating down that river for 18 to 24 hours, while you're doing the things you normally do this one extra thing. And I know that reliably we'll get that function every time you eat the bacteria, no matter what your microbiome looks like or anything, because it's totally agnostic to that. It's not trying to join the microbiome. So the idea was like sidestepping all the complexity of trying to seed the gut or have a bacteria take up residence, which is really unreliable and inconsistent. Instead, pick one that just transits right through.
What about packaging of food stuff with, subtleness, so that while it's on its journey, it has plenty of fuel to multiply as much as it can before it leaves your body and have its effects?
Yeah, so we decided early on, I decided that what I wanted was, I didn't actually care or really want to encourage multiplication, that we could have a lot better control over the dose if we used Bacillus cereus, which, it's going to replicate maybe one or two cycles, but it's not really going to grow a lot. It's just going to pass through. And so what I did instead was I engineered it so that I knew that it would express a lot of the protein without having to replicate. So the protein that's providing the function. So the idea that essentially that bacteria wakes up in your gut and it immediately turns on its ability to kind of express this protein to perform this function. And then as it flows to your gut, even if it's not going to grow a lot, it's awake and it's active, and it is like, as part of the genetic engineering, it is very robustly expressing this enzyme. And so, I was drawing on my background as a PhD microbiologist. This is what I did in my PhD, was really understand how bacteria regulate the proteins they express, like when they turn them on, when they turn them off, how much of a protein do they express in a given situation. There's very complex regulatory kind of machinery that happens in the bacterial genome. And so I was able to kind of tap into that expertise and ensure that the bacteria was able, that the regulation of the protein, of my protein of interest, of my function of interest, it was basically really strongly on all the time.
What function are you trying to enable?
Yeah. So with the first product, I thought, again, kind of going back to making healthy people healthier, and the idea of kind of helping people in their everyday lives as a way of kind of bringing synthetic biology and genetic engineering into kind of everyday use. I made a bacteria that could break down acetaldehyde. So the function of performing was breaking down this toxic molecule called acetaldehyde that is the metabolic byproduct of drinking alcohol. I mean, acetaldehyde is the reason that you don't feel so good if you've had a few drinks the night before. If you wake up the next day, you don't feel so good. That's in large part due to your exposure to this toxic byproduct called acetaldehyde. And acetaldehyde initially actually forms in the gut when you drink. And then it kind of gets absorbed in the bloodstream. It wreaks havoc throughout the body, and it's eventually processed by the liver. But at that point, it's a little too late. So we engineered the bacteria to perform the same function your liver does of breaking down acetaldehyde, but doing it in the gut where it initially formed. So the idea was that you would eat this Bacillus cereus, it would pass your stomach acid unharmed, it would wake up. When it got into your gut, it would start expressing this enzyme that could break down acetaldehyde, and it would do that really, because of the genetic engineering, it would do that really robustly. So we could break down as much acetaldehyde as you might be exposed to drinking, and then you pass it out the other side, and it would work for a night basically, which is how long you'd need it in the case that you're drinking alcohol.
Well, do you have it before you drink, while you're drinking, after you drink?
Ideally, it's designed to be taken before you drink, so that the bacteria is out in your gut, hanging out in there for, like I say, about a day, and so then it's ready and it's making this enzyme, so that then when you drink alcohol, and then alcohol gets the ethanol, and a small percentage of that gets converted to acetaldehyde in the gut, that acetaldehyde, our bacteria are ready to take care of that acetaldehyde before it gets absorbed into the bloodstream. So that's fundamentally the hypothesis behind how the product works. So you take the product before you drink, and then the bacteria are ready, and they're in there to kind of deal with acetaldehyde as it forms.
Okay. What makes acetaldehyde? Is it just literally the breakdown of alcohol by stomach acid, or our cells?
Our human cells, and by in large part in this case, it's the bacteria. So what happens normally is, so when you drink alcohol, right, the ethanol, which is the part that, is the functional part of alcohol, right, of an alcoholic drink, it is alcohol. That ethanol, the vast majority of that gets absorbed pretty quickly into the bloodstream. And then the ethanol circulates throughout your body and has the effect that it has, the intoxication and whatever else kind of ethanol does. And then it makes its way to the liver. And then in the liver, that ethanol is broken down from using two separate enzymes. So one enzyme converts the alcohol, the ethanol, into acetaldehyde, and then a second enzyme converts the acetaldehyde into acetate. And acetate is essentially vinegar. It's innocuous. It's and at that point you sort of detoxify the molecule. The good news is that this is how the vast majority of alcohol is broken down, and the liver is very effective at this. So it can do both steps really quickly. So the alcohol makes it all the way to acetate no problem. The problem is that a small amount of the ethanol you drink before it gets absorbed in the bloodstream, a small percentage of that actually gets broken down by enzymes that the bacteria in your gut make, and they convert that ethanol into acetaldehyde, that same first enzyme that the liver uses. But they don't do that second step of converting the acetaldehyde into acetate. So even though it's a small amount of alcohol that's being broken down in the gut, it actually is the major source of acetaldehyde in the body. We see that like in the scientific literature is well established. This is called the bacterial colonic pathway of alcohol metabolism. And so basically the bacteria in your colon break down a small amount of alcohol. It's not relevant in terms of intoxication, but all of that alcohol gets converted to acetaldehyde. And then colonic acetaldehyde levels subsequently rise to 5 to 10 times higher than blood acetaldehyde, because the liver is so effective at both steps of the reaction, but the gut is not. And so then that acetaldehyde basically accumulates in the gut. It's absorbed in the bloodstream. It circulates throughout the body and wreaks havoc throughout the body, and then eventually is broken down by the liver. And so the idea was we just completed the reaction in the gut. Same type of enzyme that your liver is using to do that second step. We just have programmed another bacteria to do that same second step, the same way many bacteria are doing the first step.
Could this be reconstituted as an injectable liquid for alcohol poisoning? I mean, would it, let's say someone drank so much that they're blacked out and now they're unable to help themselves. Could this become a hospital protocol where, again, through IV, you give a mixture of this, and the bloodstream may be very dangerous, I don't know. But is there a way to do something like a bolus of this, administered orally somehow through a tube, or maybe even a suppository, something to mitigate the effect of alcohol poisoning?
So with alcohol poisoning, what you're dealing with is actually like the toxicity of the ethanol itself, not the acetaldehyde. And so this bacteria is really, its ability is to break down the acetaldehyde, this metabolic byproduct, which is also quite toxic, but that's not, the problem is that when as I say, the vast majority of the alcohol you drink is absorbed in the bloodstream pretty quickly and processed by the liver. And so in the case of alcohol poisoning, you're kind of overwhelming the liver's ability to even break down the ethanol. And then that ethanol itself is sort of poisoning your brain and causing the problems, suppressing kind of respiratory and function and things like that. And so that's what can create that problem. So this bacteria is not dealing with the ethanol at all. It's only the acetaldehyde.
So what happens if someone's really, really good and fast at processing ethanol in the liver? So they would have a certain profile. They would build up acetaldehyde very quickly. And someone else maybe that's slower to metabolize it, or a whole stomach. What happens if you've got a lot of conversion of ethanol, but there's very little acetaldehyde, or conversion in the presence of a lot of acetaldehyde? Is there a feedback mechanism that slows the decomposition of ethanol to acetaldehyde, let's say?
Theoretically, like the enzyme kinetics say that yes, at some point it would. From a physiologically relevant standpoint of concentrations of ethanol and acetaldehyde, that's unlikely. There actually is some people have a mutation in the enzyme that breaks down acetaldehyde. And so they actually are exactly that. They can convert the ethanol very quickly. Or some people actually have a mutation in their ethanol, the enzyme that breaks down ethanol, and converts it into acetaldehyde. And that enzyme actually works more effectively than a normal person's. And so they actually do also get an accumulation of acetaldehyde. So at some point, yes, it is true that if the acetaldehyde builds up too much, it'll create a backward pressure on the enzyme that does that conversion. But the vast majority of cases, that's not an issue.
Is there any point in affecting the rate of ethanol conversion to acetaldehyde, or is it only negative, or do you just leave that to the body?
I mean, I would argue that I think the risks outweigh the advantages of accelerating conversion of ethanol into acetaldehyde. You talk about an edge case where somebody is drinking too much and then they get poisoned or sick but that's really the choice of the ingestion that this product, that what you're describing, would help. In most cases, it would just be like to drink slower, or with food like slow absorption, because the acceleration of ethanol to acetaldehyde will result in a higher accumulation of acetaldehyde, which acetaldehyde is much, much more toxic than ethanol. And so a small amount of acetaldehyde causes a much bigger problem than a small amount of alcohol. So you wouldn't want to optimize for more acetaldehyde buildup. You want to optimize for less. Like, if anything, you want to slow down the ethanol breakdown and speed up the acetaldehyde breakdown.
So I'll give you an example. Like myself, I had a very short drinking career. By the time I was 29, not only would I be hungover the next day, but I'd be hungover like the night of. I said, no point drinking anymore. But why does that happen? Why are some people able to drink for decades and seemingly be okay, but they're probably alcoholics? And other people, they crap out early. They can't process it. They start to get hungover more and more and more frequently and fast and more early.
Yeah. I mean, basically, the short answer to this is that like everybody's biology is a bit different, and like the function of your liver declines over time. So the enzymes that your liver uses to break these alcohol and acetaldehyde down, our production of this enzyme slows down over time as our liver becomes less functional. And so for some people that happens sooner, and for some people that happens later, and a lot of that's up to genetics. It's actually a lot of it's up to your microbiome too. The fact that, I mean, like people will notice that maybe 2 nights that are separated by a couple of months that seemed very similar on the surface, right? In both cases, they went out and they had, let's say, 6 or 7 drinks and over a pretty similar course of time. And one morning they woke up and they felt fine. The other morning they woke up and they felt terrible. A lot of times that's due to the fact that your microbiome shifted. And so the bacteria, which is kind of your first line of defense with anything you're ingesting in your body, it could be really different. So if you had a microbiome that was particularly ambitious at breaking down the ethanol into acetaldehyde in the gut, you can have a higher incidence of sort of like acetaldehyde accumulation in the gut, and then you feel worse the next day. Whereas maybe you had a microbiome that was less ambitious in that regard and left most of the job up to the liver and you felt okay. To your point, I mean, as we get older, everybody notices, or most everybody notices, that they start to feel worse after fewer drinks. And that's really just the fact that we're not doing as good a job of, our liver is not doing as good of a job of detoxifying the ethanol and the acetaldehyde over time. And so that's just one of those kind of facts of age. And so in addition, so ZBiotics is really about gut-derived acetaldehyde, and we respond worse and worse to that over time. So it can be really helpful as we get older. That being said, responsible drinking habits and not overburdening your liver are going to become more and more important as well. So ZBiotics is definitely not a get out of jail free card. It's meant to support, kind of the natural systems that are already happening. If those natural systems are slowing down, that needs to be responded to at the change.
Okay. What are the toxic effects of acetaldehyde, and what organs or parts of the body or tissues are targeted, and what's the effects?
To be honest with you, I kind of can't get into that because it's sort of be an implied health claim if I describe the specific effects of acetaldehyde.
You said it was toxic to the body, though.
Right, it is.
Have the ZBiotics make any claims there, but acetaldehyde itself, you said it's toxic. Are you able to, in the literature, there's probably documented effects, right? What does it say in the public domain about it?
There are a lot of things that acetaldehyde does, but as I say, I mean, I think I would hate to imply that ZBiotics is sort of helping with those things in any way.
Forget about the ZBiotics just for a moment. Just purely acetaldehyde. Let's pretend there was a world with no ZBiotics in it.
Right.
What are the negative, why does acetaldehyde cause negative physiological effects?
So, generally speaking, I'll speak in generalities here, so that aldehydes in general are extremely reactive molecules. So they are very promiscuous in terms of their chemical reactions. And so they have basically a double bond to an oxygen. And so that double bond is very able to bind to a lot of other things, including so it can bind directly to protein. So it's a highly soluble molecule as well. So it's able to dissolve quickly out of the intestines into the bloodstream. And then from the bloodstream, it's able to dissolve into all the cells of your body. It's able to get in your muscle cells. It's able to get into your blood, your brain, all these things. And so once it's in those cells, it can react with proteins that are supposed to be performing functions in there. And basically by binding to them, mess up the function of that protein and act kind of like a gear in the works. It also can bind directly to DNA. And so then in the same way, also kind of gum up the works of the cell. And then it can cause a cell to die, essentially. So acetaldehyde is highly cytotoxic. It can kill your cells. And so that's clearly shown in the literature. That's easy to demonstrate. And so what happens is that it can create all the cell death in your body, which when a cell dies, especially if it doesn't want it, if it's not sort of like a programmed cell death, it's sort of if it's something like this, it releases a bunch of intracellular material out into the environment, which triggers your immune system. And then you have this huge amount of inflammation your body is now responding to some sort of insult. And so the immune system gets activated, and that creates systemic inflammation, which creates kind of that hot, sticky death feeling that you have, because as your body's sort of getting inflamed, as you're dealing with kind of this mess. If you picture a bull in the china shop, breaking up all these cells, and then it's sort of your immune system's out being activated and rushing in to kind of clean that stuff up, that can create a lot of problems. And so you can imagine kind of all the damage that's happening due to this inappropriate inflammation happening from this chemical that's killing your cells. So at that zoomed in level, that's what's happening, and the manifestations of that chronically can be pretty gnarly. But in an acute situation, what it is really a lot of that sort of that malaise and that kind of toxic death feeling you have the next day is in large part due to a lot of cell damage and then responding inflammation.
I see it. So bacteria you have that breaks down acetaldehyde, so it speeds the breakdown of it, which is great. What does it break it down into? Are you able to say that?
Acetate. So same function as in the liver. So it converts from acetaldehyde, which is a highly reactive aldehyde, into acetate, which is essentially vinegar. It's a short chain fatty acid, and short chain fatty acids, as we know, are actually beneficial to the microbiome and to the gut lining, anti-inflammatory. There's a lot of really nice benefits there. And so a lot of things happen to the acetate after converts to acetate, but from a toxicity standpoint, the molecule is totally detoxified at that point.
Yeah, what's the role of acetate in the body? Does it have a beneficial function similar to butyrate and stuff like that?
Yeah,
for
exactly.
bacteria?
So butyrate, propionate, and acetate are the three kind of most common short-chain fatty acids, and they have similar kind of effects and benefits. In truth, we're talking about a small amount of acetaldehyde being converted into a small amount of acetate. The dose makes the poison when it comes to acetaldehyde. So it's not on an absolute level a lot of acetaldehyde that we're dealing with in the gut. It's just that small amount can create a lot of damage. And so that small amount being converted into a small amount of acetate realistically is like the amount of acetate you'd be exposed to if you ate like a pickle. It's not very much, but it is indeed, acetate is a beneficial short-chain fatty acid. And so the fate of that is that probably a large part of that, pretty quickly probably gets metabolized by your microbiome, and the microbes that feed on that, can produce some anti-inflammatory molecules or stimulate mucin production. But in reality, that's really kind of a small activity.
Yeah. Where does the breakdown occur? So it's not in the stomach. It's the small intestine or large? Like where does this happen in the body?
Largely the large intestine, but also small intestine to some extent as well.
Oh, okay. So all the way to the large intestine is where now the bacteria are able to convert the acetaldehyde.
Yeah, you're right. Exactly. So, why we're talking about a relatively small amount of the alcohol at that point, right? Most of it's been absorbed by the time it makes it there. But, all the microbiological activity, all the bacterial activity, or not all of, but the vast majority of it is happening in the colon. So any alcohol that gets that far down or even maybe part of the way through the small intestine, it's going to start, more and more the bacteria are going to be having going to take more of a bite at that ethanol as it makes it down that far. And so when it does, that's when the acetaldehyde gets formed, and then that kind of starts to accumulate. And so we're trying to kind of eliminate that sink as it's being.
Okay. Well, very cool. And how long has your product been on the shelves and in use by people? And how many, ballpark, how many people have used it, you think?
Yeah. So we launched the product about 4.5 years ago and, grown a ton since then. And that's been really fun to see. And so, I think in December, we crossed 3 million bottles sold. That's the orders of magnitude. 3 million bottles were sold. I think, that threshold was reached there. So that's, hopefully, about 3 million mornings that are better. Not the bacteria, but not there for a while.
Well, what have you been hearing from customers? What kind of feedback do you get?
Really positive feedback, which has been great to see. We did a lot of testing early on, but you just never know how people are going to really respond, whether or not you're creating the benefit, whether people can perceive that benefit or are excited about that. But that's definitely what we see. So I think, we have really high customer retention, really high loyalty, very high star ratings when you look on kind of third-party review sites and things. And so everything's very consistent with the fact that people are very satisfied.
What are they saying? What are some of the comments that you smiled and made you feel good?
Well, a lot of people say that this really, I think my favorite ones that I read are ones where people say that I'm so happy that I'm able to go out and have a few drinks with friends and then still make my morning workout. That's the best one. And that's the one we get a lot is, we see this product is really valuable for people who live full active lives and they have important things they want to get done the next day. And, the fact that having a few glasses of wine with your significant other or going out and having a few happy hour drinks with your coworkers shouldn't be a zero sum where you have to kind of pay for that the next morning without being able to go out and maintain your healthy routines the next day. And so the ones that make me smile the most are the ones where they basically verbatim kind of say those sorts of things and just say oh, I'm just so excited. I had a guy send me a screenshot of his Strava where he'd done a 13-mile run the next morning and kind of listed out the drinks he'd had the night before. And it was just things like that are just really awesome to see because the whole goal is here allowing people to kind of get more out of their lives and have fun and enjoy things with their friends, but then also, live positive.
Yeah. When is too late to take it? Is the morning after too late or
yes.
When?
The morning after is definitely too late. At that point, the acetaldehyde has already wreaked havoc throughout the body. And so now you're not even dealing with the acetaldehyde anymore. You're dealing with the inflammation that the acetaldehyde caused. So, basically the product will help with any drinks you have after. So if you drink 2 drinks and then remember to drink ZBiotics and then have 2 more drinks, then it will help with the 2 drinks you had after you drank ZBiotics. If you have 5 drinks and then remember to take ZBiotics right before you go to bed, odds are that's going to have pretty limited impact or limited benefit at that point, but it's probably too late.
All right. Is there anything that you can do once someone, the morning after to help the hangover, or is there nothing you can do right now?
I mean, at that stage, right, it's sort of the age-old question that people have been asking for the 6,000 years of human history that people have been drinking alcohol. There's not a lot you can do there. I mean, at that point, if you're already feeling bad, it's really a matter of time. There is evidence that caffeine and, NSAIDs, right, like aspirin or ibuprofen or whatever, they can obviously help with some of the symptoms, but they're not, mostly going to have to just kind of wait it out. Importantly, I'd say one kind of myth I really like to dispel is that next day has nothing to do with dehydration. That's sort of this pervasive myth that alcohol dehydrates you and that you're dealing with dehydration the next day. And that's just not true. It's been well demonstrated demonstrated that alcohol, while ethanol does bind to the antidiuretic hormone, which is where kind of the hypothesis came from, that it must dehydrate you then. And while that biochemistry is true, that inhibition of antidiuretic hormone is not enough to significantly dehydrate you, especially given that the alcohol you're drinking has a lot of fluid in it already. And so it's been well shown and documented that like the biochemical markers of dehydration, like vasopressin, things like that, are not correlated with hangover severity. And there's no like electrolyte imbalances or sugar imbalances, as things kind of like, it's all these sort of like electrolyte kind of beverages that people are touting as a way to sort of like, prevent a hangover. It's just like, there's no data on that. In fact, there is a lot of data that shows that that's just not the case. And so not to say that it's harmful, right? Like hydration is always valuable, right? Your kidneys and your liver are working overtime to help you deal with this like highly toxic, set of molecules, ethanol and acetaldehyde. So it's always good to support them and increase your blood volume. And it's never a bad idea to hydrate, but that's not what's causing the issues you're dealing with.
Why do people feel so dried out then from the alcohol? Like,
I mean, that's the argument, right? Is that like, if it was just dried out and thirst, then like drinking a glass of water the next day, you'd feel better. And that's definitely not the case. So there isn't, I think that like dry mouth is sort of can be a side effect of drinking alcohol. But I think, that's more to do with kind of the deal with the fact that your body is sort of fundamentally like you create a lot of inflammation, there's a lot of fluid and to deal with. Like the same way that you want to make sure you stay hydrated when you're sick or whatever. But dehydration is not the cause of what you're dealing with.
Interesting. Have you had anyone that's used, like that drinks very frequently and uses it every week for a period of months? And, does the effect just work every time, or does it grow with time? Does it diminish with time? Any heavy users of it?
Yeah, I mean, definitely lots of heavy users. We have, a good portion of our revenue comes from, people who are really excited about the product and use it a lot. What we see is that like basically the more somebody uses it, the more they basically, we hear kind of the sentence like, I'm afraid to drink without it now. And so kind of using it every time they drink. So we have a lot of people who use it very frequently. And we sell the product in bulk in 50 packs and 100 packs for that exact reason, that there are people that basically just use it all the time and hand it to their friends. And no, there's no expectation of, nor do we observe any sort of like quote unquote like tolerance or like your body like adapting, right? Because talking about a small amount of acetaldehyde, the vast majority of the enzyme that you need, your liver already is producing to deal with the vast majority of the alcohol that's being absorbed and processed there. And so we're really dealing with a small amount of acetaldehyde that's forming in the gut. So there's not really any risk of like tolerance or adaptation that happens there.
Have you thought about doing this for, let's say, marijuana use, feeling burnt the next day? Is there any physiological mechanism or help there?
I've never even looked into that. It certainly is an interesting idea. I'll say that the bigger mission of the company is, I liked this as a starting place for the technology. What I was really excited about was the idea that we could take probiotics and engineer them to do useful and beneficial things that for people and make people live healthier, happier lives. And in the early day, and then I didn't necessarily think that I was going to be using this to help you kind of with the next day effects of drinking per se. I just kind of had it on as I was sort of brainstorming ideas. It was one of the ones that made the list, truthfully kind of almost as a joke in the beginning, just sort of like, oh, haha, this is something we could do. And then, but as I started pitching the idea, that was the idea that people got most excited about. And so I started to realize that this was like a really great starting place for the tech, in that I'm sort of like doing this birth announcement, right? When we launched this product, Amara, I said this already, it was the world's first ever genetically engineered probiotic of any kind to go to market. Nobody had ever done this before. Nobody ever brought this technology to market before. Other people had done it in research labs or working on it for drugs or things like that. But like we were the first people to bring this technology to market. And I remain very excited about the potential for this technology of genetically engineered probiotics. So this next generation, right? Probiotics that are engineered to do something very specific and create a new novel benefit, to perform a function that did not exist before. And so, I mean, in terms of a product. And so I was really excited about that. And so this became clear that this was a good first application of tech to announce this idea of this probiotics 2.0, these genetically engineered probiotics, right? An age-old problem that nobody seemed to have a solution to, but there was like clear biochemistry that we understood that we could address, which is the acetaldehyde buildup. And so I thought that what a great way to kind of prove the point, right? People understand the problem. There's a very visceral readout of efficacy, right? People can try the product and feel the benefit for themselves, so they know it's working. You don't have to just take my word for it. You can feel it. So that made sense. But that being said, we want to apply the technology, and we are actively looking to kind of make lots of new products that perform all kinds of useful and exciting function. And so it's not so much about necessarily, making you feel better after kind of partying per se. That just so happened to be kind of the first place we went. But I think that there's such a breadth of exciting things we can do. Like we can help you acquire nutrients better from your food. We can help protect you from like heavy metals in your drinking water, or pollutants in the air. Things are just unavoidable in a modern environment. We can help you like turn kind of like the negative aspects of like a highly processed diet that are unavoidable into things that are more beneficial for human health. We can help with your mood and your sleep, oxidative stress from even things like exercise that while obviously are genuinely very good for you, also create stress that, that your body has to recover from, and it can help you maybe recover better or recover better from poor sleep. So there's so many exciting things I think we can build here. And so your idea around sort of I don't know what you call it, the fry after marijuana use, that's super interesting. I never even looked into it, but if the biochemistry has been defined and there's a lever to pull there, it's certainly something that theoretically could work. Although the route of ingestion I guess people do eat edibles and stuff, so I don't know if it comes from that, but generally the route of ingestion for marijuana is to the lungs, so maybe a little bit more tricky that back.
Very good. Where is ZBiotics available? How do people get it?
You can get it on our website. ZBiotics.com is the best place to get it. We also, are sort of hoping to expand more into retail this year, and so that's another option as well.
Okay, well, very good, Zach. Thanks for coming on the podcast, and I know we went into a ton of detail on it, but fielded everything well, and I appreciate it.
I mean, really impressed. Really astute questions and really insightful, and I was really happy we were able to get into the biology. That was a lot of fun for me, so thanks a lot.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.